Phosphorus in Water Quality and Waste Management. Taking a look at the Integrated Waste Management book, we need to understand what this is and how it works. So phosphorus is a key element for all living systems. Phosphorus is a component of DNA and RNA and indispensable for energetic metabolism, ADP and ATP of living beings. Phosphorus cannot be substituted in these biological functions by any other element, and the tremendous growth of global population is therefore linked to a proportional increase of phosphorus requirement for the production of food, which actually to a large extent is depending on the use of mineral phosphorus fertilizer. Many natural aquatic ecosystems are controlled by restricted availability of phosphorus, which represents one important factor for high biodiversity. The anthropogenic increase of phosphorus flows, therefore, has the potential to cause severe negative effects on natural aquatic ecosystems. Roughly to 80-90% of extracted phosphate rock is used for food production and nutrition. Given that P is an unrenewable resource, the global reserves are limited, and the aspects of scarcity and recycling recovery have considered. Today's global mine production reserves of phosphate rock ranges from 26 to 34%, are reported at 160 meno and 16 billion tons, respectively. This gives a static lifetime for the reserves of 120 years, a number which has been similarly reported by several authors before. Phosphate ore is produced mostly from open-pit mines, resulting in dust emissions and large quantities of tailing mining wastes, and report material energy consumption data for the production of P2O5. Another major waste is produced at a later stage, when wet phosphoric acid is produced from phosphate rock concentrate using sulfuric acid. This is called phosphogypsum and is normally disposed at sea or in large-scale settling ponds. It has very little use because it contains considerable number of impurities such as cadmium and radioactive elements. The above-mentioned coverage times show that there is no urgent scarcity problem appearing at the horizon, but following aspects to be considered. First, the relevant reserves of phosphate rocks are highly geographical, concentrated in China, Morocco, West Sahara, South Africa, and the U.S. The largest world producers are China, followed by the U.S., Morocco, and Russia. The largest economies, such as Western Europe or India, have virtually no domestic supply and are dependent on imports, and this is one major ingredient for geopolitical unstable situation. Second, the quality of extracted phosphate rock is continuously declining, meaning the content of hazardous substances such as cadmium and uranium is rising. And this will require the employment of constantly decapitation mining process in the future, if agricultural soil shall be further unprotected and not be used as a sink for heavy metals. Third, population growth, the nutrient conditions of soils in developing countries, and changing nutrient patterns will entail increased demand of fertilizers. The Food and Agricultural Organization predicts annual growth rates between 0.7 and 1.3% until 2030. Which would mean an increase of some 25% phosphate rock consumption compared to now. The Population Division of the Department of Economic and Social Affairs of the United Nations Secretary predicts 9.2 billion people in 2050. That is an increase in 37%. Consider these factors. Similar market effects, price volatility currently are the case for crude oil, have been anticipated for phosphorus fertilizers in the future. So we can see the production stage here. We can see the input and the output of what's going on. Now, taking a look at water quality, phosphorus is limiting the nutrient for algae and autotrophic growth in most freshwater bodies, and some coastal water is influenced by river discharges. The anthropogenic discharge of phosphorus to these waters therefore increases the potential for algae growth, which is the starting point of eutrophication. Eutrophication is categorized by the increased availability of phosphorus for primary production algae, which represents the basic substrate for aquatic ecosystems. Even moderate anthropogenic increase of P availability influences the competition between species, which results in changes of aquatic ecosystems. And beyond certain thresholds of phosphorus discharge, the ecosystem shifts to a completely different status with steadily increasing deterioration of water quality. In natural environments, phosphorus is mainly present in particulate forms as minerals with low solubility, and the availability for phosphorus for plants and algae is therefore quite restricted. Hence, in many natural aquatic ecosystems, life is limited by phosphorus deficiency. And we can see municipal and industrial wastewaters, drainage from agricultural land, excreta from livestock, and diffuse from urban drainage. And we can see the source of P in wastewater from plants, animal, and detergents, household, and from other different factors as well. And then we have a method for phosphorus elimination, mechanical, chemical, and also crystallization processes as well. So what we can take away from this is that phosphorus comes from many different forms, and it is an issue when it comes to waste management. That's why it's always a good idea to periodically test your water for high levels of phosphorus.